In question number 19, we have a spring compressed between two objects of unequal masses. So I'm going to make a quick sketch here. We have a larger mass on the left, and we have a smaller mass M on the right, and they're held together, and then they're released. The objects are initially at rest on a horizontal frictionless surface, and they want to know what happens. We know that they're going to go to the left and to the right. When we let go of the spring, that's what's going to happen. Now, the smaller mass on the right means that this object will be going faster. Its speed after the explosion event, which is really what this is going to be larger than it is for the mass on the left-hand side. And so, some of the questions are really teasing out whether you understand the vector nature of impulse and momentum. So impulse and momentum are vectors. Momentum is abbreviated with a capital P, and impulse is abbreviated with a capital J. And scalar quantities are work and energy. I'll just write energy as E, even though we often use, things like capital U sub G for gravitational and et cetera, et cetera. Okay, so the kinetic energy is the same as before the release point. And we know that that's not true because kinetic energy is a scalar. So the object on the right-hand side, let's call that object number 2 is moving to the right. It's going to have some non-zero kinetic energy, and it's definitely not going to be negative, right? So it's just a value. We don't assign a negative in terms of direction. And if this is side number 1, it's also going to have some kinetic energy. So it's not going to be 0. And the kinetic energy after this spring is released, or this explosion, is non-zero. And it was 0 when it started. So A is true. B is not true for the same reason. So the final kinetic energy is 0. The two objects have equal kinetic energy. That's not true because kinetic energy is defined formally by 1/2 mv squared. Because the v is squared, it has a much more profound effect on the energy. So even though they have different masses, the object that's going faster because of that exponent is going to have more kinetic energy. And the speed of one object is equal to the speed of the other. We've already kind of answered that. We can see why that's not true. And the best answer ends up being E. The momentum before the collision is 0. The momentum after the collision is also 0. The momentum of object number 2 is going to the right. The momentum of object number 1 is going to the left, so it's negative. And when we add those two things up together, we have to have the momentum that we started with. This is conservation of momentum. The momentum before the event is 0. The momentum after the event is 0. And so our best answer is E.